Bismillahirrahmanirrahim. This is the power supply unit in your lab, and this is the load consisting of a number of bulbs which can be turned on with the help of these switches. This one is the power supply unit, a variable transformer with the help of which you can vary the AC supply to this unit. These are volt and ammeter, and this is the speedometer, and this is the power supply unit which can measure voltage and current. This is your first machine, that is the DC series machine, and you can read its nameplate data. Here are the terminals of the different windings of the series machine: shunt, series, and the armature winding. And this machine is the shunt machine. Armature and field windings are shown over here, its terminals. So this is the overall setup at which you are going to perform your experiment related to the load test of the DC series motor. Now let's start making the connections. First of all, the supply will be connected with the measuring unit. So here you can see the connections. Supply of 300 volt 6 ampere. We are taking its connection and we are giving it to the measuring unit. Then from the measuring unit we will give the supply to the armature winding of the series machine. We will connect the armature in series. So here you can see we have connected it to the terminal A1. Then we will take the second supply terminal and we will connect it to the D1. In order to make it a series machine, we will connect A2 and D2. So now this is set up. So we are giving supply to this machine which has been configured as a DC series machine. This is working as a motor because we have given the electrical supply to this machine. Now let's configure this second machine as a generator. First of all, we will connect field and armature in parallel because we want to configure it as a shunt generator. So here you can see we have connected A1 and F1 and A2 and F2. Both of them are in parallel. Now we will take supply from this armature and we will connect our load with this one. So we are going to connect wires with A1 and A2. That is a set of terminals of the armature winding. So from this armature winding we are going to supply our load. So the load will be connected in parallel. So it will be connected like this. Now you will be turning on the switches and you will be applying the load at the DC shunt generator. If there is no voltage developed, then you will have to swap the connections across the field winding in order to get the voltage over here. We need to measure the voltage and current at the load. So now we will add voltmeter and ammeter in the connections to observe these two parameters. So first we are going to use the ammeter that will be in series with the load. So you are going to use these two terminals. Ammeter should be in series and voltmeter should be in parallel. So if we are going to use this machine, this meter as an ammeter, so you can see its scale. So it should be in series. So we are going to connect this ammeter in series, so that you can see from the load we are going into the meter, and from the meter we are going back to the armature terminal. So this ammeter is in series with the load and that is connected in parallel to the armature. So now we are going to connect voltmeter in parallel to the load. So we will take one wire from one terminal of the load and the second wire from the second term, and here you can see the scale, it is on voltmeter. So we are connecting this wire. Voltmeter is in parallel and set on the voltage scale. Here you can see voltage terminal, and for ammeter you are going to use ampere terminals, the terminals which are to be connected in series. Okay, so this is the speedometer, and it measures the speed by observing the reflections from the sticker which is pasted at the shaft. So now our setup is complete. Okay, now we will turn on the supply, and we will increase the AC voltage, and that will increase the DC voltage at the series machine terminals, because in the power supply we convert AC into DC, and when we increase AC voltage, the DC output will also increase at the output of the rectifier. So here you can see the load, because we are getting voltage at the shunt generator terminal with the increase of the speed of the DC series machine. So if you will increase the speed, you will see more voltage will be induced and the brightness of the bulbs will increase. So now we will observe the behavior of the machine with the increase of the load. And that you will observe that if we increase the load, the speed of the machine will decrease. So here you can see we are turning on the bulbs and the speed is correspondingly decreasing. So with the variation of the load, the speed will change. We want to observe that speed change in this experiment with the variation of the load. And of course, when the speed is going to drop, the induced EMF will be reduced, so the brightness of the bulbs will go down. In order to have high brightness, what you will have to do, you will have to have more voltage, and for that you will have to increase the speed. Now you can see we have increased the speed. This is the induced voltage, and this is the input voltage and current that your series machine is going to take. Now we will turn on the bulbs one by one. First bulb has been turned on, and you can observe the speed now. It has dropped a bit compared to the no load. This is the voltage, this one is the current, 0.35 ampere is the current being taken by one of your bulb. Check the scales. Input power can be observed from this measuring unit. So second bulb has been turned on. Now you will observe the speed is decreased now, and the voltage is also reduced. The current has increased, the voltage dropped because of the increase of the load current, and voltage and current over here can be multiplied to get the DC input power. And now you will increase the load, you will observe more decrease in the speed, and you can observe the machine connections over here. Voltage, current is the terminals of the shunt generator, and here is the input voltage and current to your series machine. Series machine is acting as a prime mover over here, providing mechanical input to your shunt generator. Shunt generator is giving you the voltage, converting that mechanical energy into electrical form, and we are connecting the load across the terminals of the shunt generator. So in this way you will keep on increasing the load, you will observe the readings, input power, output power, the speed, and then as per instructions given in the manual, you are going to observe the characteristics of the series machine, series motor that is over here. Please note that there are two windings in this series machine in the lab. One is the one which can be connected in series and one which is for parallel connection, shunt connection. F1 and F2 generally represent the winding which are used, which is to be connected in parallel to the armature, and D and D2 represents the series winding which will be connected in series with the armature. So you will keep on increasing the load, you will observe all of these things, and then as per instruction in the manuals you can draw the characteristics of your machine. So rest of the video is just to observe the experiment and to note down the readings, and then you can plot the graphs for the characteristics. So now you are supposed to see the rest of the video and record the observations and complete your manual. Thank you very much.